I'm going to get Qubit fired up here. And I should, so neither Charles and I have used Trellis. We are both still using Qubit. I use Qubit 14, which is not available through CSIMsoft. CSIMsoft, instead of Qubit 14, they're providing Trellis, which is their version of Qubit now. And Charles, I believe, are used to using Qubit 13.
Yeah, 13.2.
But so far we've not heard from any users having any problems running examples using Trellis. So we assume that they still everything within sort of that worked for Qubit 13 certainly seems to be working for Qubit 14, and also seems to be working for Trellis. So I'm going to, I have Qubit fired up here, so I'm going to show that on the screen. You may want to go to full screen mode so you can see it closer to the resolution of your, and be able to read the text. So this is what the Qubit looks like here in the main portion. We have our graphical user interface. This is where our meshing will occur. We have a command line interface down here at the bottom. On the right side is our command panel that's used to do sort of graphical user interface commands. On the left side, we're able to sort of see the file geometry. So materials, groups, blocks, volumes, most all the geometry will show up under the volumes. Down here we have our properties page, so when you select something, we'll see the properties of that. And then down here at the bottom is the apropos information. So whenever we create variables, you'll see the variable name and the current value coming up. Up here at the top or left, we have these are all of these little scrolls related to the journal editor. Then we have sort of viewing things in different types of sort of whether wireframe or solid, whether it's transparent. Then we have the display the geometry, mesh, information about our boundary conditions, and then sort of all of our viewer information, such as toggling the online scale, zooming in, centering things. And then over here, let me try to see if I can drag these things down. So these are selecting our filement nodes, curves, triangles, quads, hexes, and then we have our groups, volumes, bodies, volumes, surfaces. And so if you only want to be able to select curves, you can toggle them on and just select curves. So we're going to get started by, we need to tell it what directory we're going to work in. So let's go here. I'm going to use Power 1.9. I'm going to go to examples 3D X8 and our mesh directory there. So and you see our down, you can see in our command line here that it gave the essentially the command equivalent to what I just did through the graphical user interface. So that's very handy to find out what command you ran and saving that command in a journal file, even if you run the command through the GUI. So I'm going to open up here our journal file. We'll start with the geometry file. So the comments are shown by the pound. So the first thing we're going to do is reset and create a brick that's 6,000 by 6,000 by 4,000. So I can right-click and play that. So here's our brick. I can rotate it by using the left mouse button, zoom in and out using my scroll wheel, and then translate using the right mouse button. You can also control that information. I believe it's up here in preferences, so I can look at what my mouse does. Control my left button left press control, middle button, right button, and so forth. So you can customize that to be what you want. Up here, you'll notice that I can do wireframe, hidden wireframe, so you see things in the background are now dashed. I can make those things in the background disappear, semi-transparent, non-transparent. I can turn off, toggle the perspective view, so now I'm in a perspective view. I can turn off the geometry, turn the geometry back on. I can zoom in, as well as, and then auto center it. And I can also turn on the axes here. So let's turn off axes, go back to transparent. So now I have a volume. I'll go back to the journal editor. We're going to move it down so the top of the surfaces is at 0. So usually we have the ground surface at 0, and so we want the top of our domain at 0. We're going to create a fault surface, name the fault surface. Boom, we created a plane within our box. It hasn't yet divided the box. All we've done is create a plane. We're going to create a material interface halfway down. We're now going to use those planes to cut. So we'll cut the fault surface. Now you see I have different colors on each side of the fault. That means I've actually cut our volume. Look at our volumes. We have a volume 1 and a volume 4. You may ask, well, where are 2 and 3? 2 and 3 are, they're the sheet bodies, which are our surfaces. So our surfaces outside of our volumes are called sheet bodies. So we have surfaces 2 and 3. Now let's cut our 2 volumes with our material interface. So now we have 4 volumes, 1, 4, 5, and 6. We're going to name them so that we can reference them later. And now we're going to, these 4 surfaces are completely independent, so they don't have overlapping. The surface in between, say, volumes 1 and 4, that's not a single surfaces, that's a pair of surfaces. And so to make sure everything lines up, we imprint all the volumes so that, and then merge all. And so that's going to take this single surface, make these pair of surfaces between volumes 1 and 4 a single surface. So then anything we do meshing in volume 1 will also show up and be consistent with what happens in volume 4. And then we need to, we're going to delete our sheet bodies, 2 and 3. So you'll also notice since we named our volumes, we see those over here. So we have our elastic X positive, elastic X negative, X positive, and X negative viscoelastic. So that's we've set up our geometry. Now let's look at our mesh. So in our meshing file, we play back the geometry. So I can just show you how that play back everything that we just did. Now we'll specify a kilometer discretization size, so volume wall size 1,000. Generate the mesh. So you can see our nice simple mesh, very easy, not a very big mesh. We'll name our blocks. So these are our different material properties. And notice that we want just 2 materials. So we combine the volumes 1 and 4 into a block 1 elastic, and then we'll do our viscoelastic properties separately. And so we name a second block with our viscoelastic properties. Then we need to create our node sets for all our different surfaces. So if we look at so here, up here, I'll click on just the surfaces. So whenever I select things, I'll get surfaces. Notice I didn't get the surface. So if I want the fault surface, I try and click here in the fault. It tends to give me the front surface. If I hit tab, that gives me the fault surface. Notice over here on the left, it says fault surface. But what is the bottom one? The bottom one is fault surface at A. So it's taken our single surfaces, and when it divided into 2, it named one fault surface and the other fault surface at A. And which one is the original label and which one has fault surface at A is essentially arbitrary. So you pretty much have to click to sort of see what's going on. So we're going to create a group, and then we're going to create a node set from that group. The reason why we create groups and then node set is that we can do Boolean operations on groups, but we can't do Boolean operations on node sets. So we'll do the x positive. So if I go over here and look at what these surfaces are, notice it says surface 20, both over here on my properties as well as down here in my command line panel. That's surface 28, so that's how I knew to put 20 and 28 in my journal file. Do the same thing with the negative x face and sort of all of the other faces. And so let's look at our groups. So I'll go up here. Here's my blocks. I can look at my blocks. So there's my elastic block, my viscoelastic block. I look at my node sets. Here's my faults. So you can see how I've selected all the nodes there. I have my x positive face, x negative. Let me turn off the mesh and it'll make it easier to see. So there's x negative, y positive, y negative, z negative. So see the bottom. And I have z negative, no fault. And so this shows up that we can't have an overlap between our Dirichlet boundary conditions and our fault, because we can't specify relative displacement across a fault if the displacements are constrained, or if that vertex is constrained in x, y, or z. So what we do is when we have our fault come into an edge, we tend to create a node set that has those surfaces without the fault in it. And so that's where in our journal file, if I go back and look at without the fault, I created the group Z negative no fault from the group face Z negative, but then I took out all of the nodes that are in the fault group. And so that was a Boolean operation that I can do using groups. And then finally, I'm going to export the mesh using the export command. It'll be an Exodus file, which is a type of netcdf file. And so there I've written a mesh. And so that gives you a very quick overview of meshing. We'll look at meshing in more detail in our second session in terms of how do you mesh in 2D and 3D and do some sort of more sophisticated things. Do we have any quick questions on this meshing part of things? I see any questions? Okay, so I'll exit out of Qubit. Let me stop the sharing there. And